Hello everyone. In this video, I want to show you some derivative table. So, from the table, we have that if you are given this function ax raised to power n, when you differentiate that, you have n times ax raised to power n minus 1. In fact, that's the general formula for differentiation. So when you are given the function sine x, for instance, if you differentiate sine x, you're going to get cos x. If you differentiate cos x, what you get is minus sine x. When you differentiate tan x, you have sec square x. Okay, I know some of you may be seeing this sec function for the first time. Sec simply means 1 over cos. Then when you differentiate sec itself, you have sec x tan x. If you differentiate cosec x is 1 over sine x. What you get is minus cosec x cot x. For those of you that are seeing cot x for the first time, cot means 1 over tan. Okay? So when you differentiate tan x, when you differentiate cot x, what you get is minus cosec square x. Then these ones are the exponential functions and the logarithmic functions. When you differentiate exponential x only, you get back the same. If you differentiate, if something is mixed at the exponent, just differentiate that and multiply with the original function. When you are given a ln function, ln x is the natural logarithm of x. So ln x is the same thing as writing log x to base e. Logarithm of numbers to base e. That's the meaning of ln of that number. So when you differentiate ln x, what you get is 1 over x. If you differentiate a number raised to power x, for instance 2 raised to power x, this is what you get. When you differentiate log x to a different base, then that will give you 1 over x into log e base a. Okay? Now, but in this video, we shall be looking at only the trigonometric functions. Now, let's look at some examples. All right. Let's look at these examples. The questions say differentiate the following functions with respect to x. And the first question says y is equal to sine 3x. So we are differentiating each of them with respect to x. Okay? So we go this way. Solution. I take the original function 1. If you watch closely, chain rule can be applied here. Now, but if you revert back to our derivative table, you are given when you differentiate sine x, then we say that the y over the x will give you nothing but cos x. But in this case, can you see we have sine 3x, so it's different from this. What do? We have to apply our chain rule. Of course, we have done chain rule, we are familiar with chain rule, and we have video on chain rule. So, we go this way. Let's assign value to this 3x. That is where the function of function is coming from. We say let u be equal to 3x. Okay? If we assign u to be 3x, therefore our y will now become sine u. Okay? Then let's differentiate each function with respect to the variable that it's dependent on. So let's differentiate u with respect to x. Therefore, we have the u over the x is equal to 3. When you differentiate 3x, what you get is 3. From the formula, if y is equal to a x raised to power n, if y is equal to ax raised to power n, therefore our dy over the x is nothing but bring down the power. When we bring down the power, then repeat the function and drop the power by 1. So that is it. So that's the formula. Okay? Now, in general, just see anytime you have, let's say, y is equal to ax, dy over the x. It's just a. No troubles. So in this case, let's go back to differentiate our y, our function y, with respect to u. Then we have dy over du would be, when we differentiate y equal to sine x, dy over the x is giving us cos x. So let's apply it here. So when we differentiate y with respect to u, what we have is cos u. Then we now apply our chain rule. And the chain rule states that dy now over the x is nothing but dy over the u times du over the x. So in this case, what did we get as our dy over the u? Our dy over the u is cos u times, what is our du over the x? Du over the x is 3. So if we do that, we have 3 cos u. But we cannot leave our answer in terms of u. We assign value to u. Okay? So we called u to be 3x. Therefore, our dy over the x is nothing but 3 cos 3x. That's the derivative of that function. Okay? So, what have we achieved? We said that if y is equal to sine 3x, the derivative simply is 3 cos 3x. So the simple shortcut of it is just differentiate the function you have here. If we differentiate 3x, that's the shortcut now. If you differentiate 3x, you have 3. Differentiate sine you have cos and put whatever thing you have there. So this shortcut is helpful when you see a question like this, a jump OBJ question, or even YF, any exam you are writing that you come across a question like this, given an OBJ, you can always use this shortcut to navigate without necessarily following this long process. Okay? Then let's look at the number 2 question we have here. So the second question says y is equal to sine x cos x. So if you look at this question clearly, you can see that this is a product rule function. So let's call this u and call this v. So by our product rule, dy over dx is just u dv over dx plus v du over dx. So that's the product rule. All right, let's start getting our parameters. We said let u be equal to sine x and v be equal to cos x. So when we differentiate u with respect to x, we're going to get du over dx. You are differentiating sine x, what will you get? Cos x. When we differentiate v with respect to x, we have dv over dx will be minus sine x. Okay? Therefore, getting our derivative, dy over dx, is just u. Our dy over dx is u. What did we call u? U is sine x times dv. dv over dx. dv over dx is minus sine x plus, what do we call, sorry, let me shift this. So, what do we call our v? V is cos x, then times du over dx. Du over dx is cos x also. Okay? Now, if we simplify further, we're going to get minus sine square x plus cos square x. Alright? So this we can rearrange to have it as cos square x minus sine square x. So, by so doing, if you can recall from your trig identities, okay, cos square x minus sine square x will give us nothing but cos 2x. And that's the final answer for that function. So, what have we achieved? We said when you differentiate what a function defined as y equal to sine x times cos x, after the differentiation, what you get is cos 2x. Okay? Then let's go back to our equation and handle question number 3. Number 3 says y is equal to cos x over sin x. So in this problem, this is a quotient rule problem. So in our previous video, we treated quotient rule. So you can go back to our previous video to see how quotient rule is done. But before that, let me show you the shortcut that you can apply while solving product rule. This is the shortcut for that same. You see the long process that we use, but this is the shortcut for it. So if you have y is equal to sin x cos x, alright, this is your u, this is your v. From the formula, keep u constant and differentiate v. So therefore, we have the y over the x. One line is enough for me to achieve the derivative of that. I'm keeping u constant. If I keep u constant, I have sin x. Differentiate v. When you differentiate cos x, what you have is minus sin x. Then plus, keep v constant, cos x. Now, I'm keeping v constant to differentiate you. When you differentiate you have the same cos x. So if you do that, this times this will give us cos square x, and this will give us minus sin square x. So we do that, cos square x minus sin square x. Alright? But from trig identities, we have that cos square x minus sin square x is nothing but cos 2x. So that's the final answer. Have you seen how short it is? Just apply the shortcut. You are there. Alright? So let's treat number 3 question. Number 3 says y is equal to cos x all over sin x. So this is a quotient rule problem. How do you know when to use product rule? How do you know when to use quotient rule? If there is a multiplication of function, therefore product rule is applied. If there is division of functions, therefore quotient rule is applied. So in this case, I will call this u, call this v. Okay? I will use the longer method to show you the step in differentiating using the product, using the quotient rule. After which, I will still adopt the shortcuts without necessarily wasting time in solving simple calculus like this. So I would say, as we let u to be cos x and v to be sin x. So let's find the u over the x. The u over the x means we are differentiating u with respect to x. If you do that, we have minus sin x. So when we differentiate v with respect to x, we have cos x. So by so doing, we say that our dy over the x, that's the formula for quotient rule. is nothing but v du over dx minus u dv over dx all over v squared. So you're going to fix all these things, all these parameters inside this program. You are done. But I will advise you, as you are learning the long method, you should equally learn the shortcut. In case you come across something like this in OBJ questions, you will not start breaking it down like this. One line is enough for you to answer this question. Okay? So, what is our V? Our V is sine x. What is our du over dx? Du over dx is nothing but minus sine x, then minus, what is our u? Our u is cos x. Then what is our dv over dx? dv over dx is cos x all over v sine square x. That's how you write the square of sine. So when we simplify further, we have this times this will give us minus sine square x minus cos square x all over sine square x. Okay? Then notice something here. We can factor out minus 1, have minus 1 outside there, will give us sine square x plus cos square x all over sine square x. But you can recall from trig identity that sine square x plus cos square x is equal to 1. So the proof is simple. So this is equal to minus 1. This big bracket is just a beautiful one all over sine square x. But when we started this video, I told you that sine one over sine x is nothing but cosec x. Alright? So this is the same thing as writing minus 1 outside 1 over sine square x. Okay? You can still go further to write it as minus into bracket 1 over sine x all squared. Okay? But what is this? 1 over sine x is nothing but cos x. So therefore, our final answer becomes minus cos sec x cos square cosec square x. So that's the final answer. When you have cosec x raised to the power 2, what you have is minus. Let me still show you shortcut that you can apply in your quotient rule. Okay? Says y is equal to cos x over sine x. Now, since this is a quotient rule problem, we have dy over dx. Means from the formula, you keep v constant. I write sine x. Then differentiate u, this is u, have minus sine x, then minus, keep u constant, have cos x, differentiate d, and have cos x also, all over b squared from the formula, all over b squared. So what do we have as our b squared? Our b squared, our b is sine x, so we have sine squared x. So from a previous explanation, you can believe with me that this, simplifying the numerator, you have minus outside sine square x plus cos square x over sine square x. Now, this is nothing but minus 1 over sine square x, which is still equal to minus cosec square x. Can you see? It's shorter, rather than wasting all the time assigning values to functions. Okay, now let's still go back to that, our last question, and that's the last question we solve in this video. The question says y is equal to cos cube 2x. Y is equal to cos cube 2x. So if you look at this question, it looks simple, but then still a bit complex. So we still apply chain rule. So we said this, watch this, let me call it, let u be equal to 2x. Then y becomes cos cube u. This cos cube u can also be written as cos u cube. Let me see assign value to this. So we call this w. W is cos u. Then our y now becomes w raised to power 3. When you remove this, call it u. Alright, so let's now apply our chain rule here. We have, in this case, let's find our dy over the w over the u, over the x. So du, let's start from here, du over the x, du over the x is equal to 2. The w over the u, the w over the u is nothing but minus sine u. Then dy over the w, dy over the w is nothing but 3w squared. 3w squared. So by definition of here we have that dy over the x is just the product of these things is equal to dy over the w times the w over the u times the u over the s. Can you see where the change is coming from? If I cancel like this, cancel like this, cancel like this, cancel like this, so what is left is dy over the x. I hope that is clear. So now let's start assigning values to them. So dy over the w is nothing but 3w squared times the w over the u is minus sine u, then times the u over the x is nothing but 2. So when simplified further, we have 2 times this and this, we have minus 6w sine u. Okay, but do we leave our answer in terms of w and u? No, we have something that depends on x. So that quickly follows that we have minus 6. We define our w as cos u, but u is 2x. So this is cos 2x all squared, like this. Then we have sine u, but u is equal to 2x. Then this is nothing but minus 6 cos squared 2x sine 2x. That's very interesting. Now, look at this point. Some students used to get something like this wrong. Some students will go and try something like this for this as cos square, then they are using this square to affect this cos and affect 2x. Then we write cos square 4x squared. Wrong. Please do not do this. Okay? Do not do this. So that square is affecting only the cos. I hope that is clear. So this is our final answer. Alright, I will leave you with a take-home assignment or a simple exercise. So in your spare time, look at this question and solve it and forward to me on the comment section. So make sure you like, share and comment. Thank you.